In this section, I'm going to talk about how to version your HTTP and REST APIs. As you think about versioning your service over time, the most important thing to consider is the overall customer experience. You have to empathize with your customers and get a sense for what kind of pain you might be putting them through as your service versions. What I put on this slide are actual customer quotes. And as you read some of them, you'll see some of the pain and distress that's been in the customer's minds. In Azure, we have two requirements to really improve the customer experience. The first requirement is that customer workloads must never break due to a service change. This is actually a policy that's been in place for many years now. But a newer policy is one where we want customers to be able to adopt a new version of a service without requiring any code changes at all. That is, the customer should be able to adopt the new version of the service, but they should also be able to adopt a new version of a client library that wraps the service and not have to make any source code changes unless the customer wants to leverage some of the new features that are available in the new version of the service and its corresponding client library. Let's talk a little bit more about the Azure SDKs and client libraries. First, some terminology. Microsoft has one Azure SDK per language. So there's just regular REST, which customers can always just use any programming language in order to make REST APIs. For that, we don't have an SDK or client library. But then we do have Azure SDKs for C, C++, Go, C# or .NET, Java, JavaScript, and others. And we may add other languages over time, and some of these may go away over time, depending on what the community at large requires from us. Each SDK has one client library per service. So there would be a client library for storage, and a client library for Key Vault, and a client library for speech recognition, and so on. Right, those are our terms that we use. There's one SDK per language, and each SDK has multiple client libraries, one per service. The client libraries provide a bunch of nice functionality over just making regular or standard REST API calls. The client libraries, they provide a service object model. So it's not just a bunch of flat APIs that are all post, put, delete, get, patch, right? They have good method names associated with them, and there's an object hierarchy. Like for storage, you have an account, and from an account you create a container, and from a container you can create a blob, and then there's 3 different kinds of blobs, and so on. Client libraries also give you code completion in your programmer editor of choice. So when you type in like blob client dot, it'll show you all the method names that are available for you to manipulate a blob. Of course, one of the great features of client libraries is that you get type safety in type-safe programming languages. So that if a method requires an integer and you pass it a string, that code won't compile. So the code you end up writing as a customer ends up being more guaranteed to be correct, and you'll find out more bugs at compile time as opposed to runtime. The client library also has support for simple patterns in it, like paging over collections, or doing long-running operations where you have to poll an operation multiple times on the service in order to find out if the operation succeeded or failed. The client libraries have support for various credential types, so that when you authenticate with the service. The client libraries have built-in retry mechanisms. As I've been talking about idempotency a lot in this course, the client libraries will automatically, if there's a failure or a throttling, they will retry the operation if there's a chance that it will succeed in the future. So that you, the customer, you basically get retries for free and exponential backoff and so on. The client libraries do client-side logging, where a customer can look at every HTTP request that's outgoing and what the response was that came in. The client libraries have telemetry support for setting up the user agent headers to send that information to the server so the service can track what kind of client libraries, what language, what version, what operating system is being used to make calls into the service. The client libraries have support for distributed tracing, they have support for cancellation of I/O requests, and much more functionality. So they really provide a lot of features over just making raw HTTP requests from a client application. When a service changes its APIs or its parameters or its payloads, well, that of course changes the API contract of the service. And then it affects all these client libraries that have encapsulated that contract as part of the API surface area. And then if that changes, that affects all the customers that are using these client libraries. So due to our rules of breaking changes where we don't want any, well, if you make a breaking change, that has this enormous impact and an enormous rippling effect that scales out and really can adversely affect the customer's experience of using your service. It can also impact the CLI and the portal and bicep tools and, of course, all the customers. A new client library must not require any customer code changes in order for the customer to have a good experience. And it's having these client libraries, it further constrains the kind of changes that a service can make. I talked about enums earlier in the course, for example. And a service might use enums in its open API specification, but because of the way client libraries in various languages handles enums, there's a lot of potential problems with using enums. Now, there's more reasons why breaking changes are forbidden. It's not just that the customer might have to modify their code, but we want a thriving ecosystem around our services. So we hope that some companies will build third-party libraries on top of our client libraries. And if you have a breaking change, it can actually make it so that the whole application that the customer wants to build is not buildable or not runnable at all. So let me explain how this can happen. Many languages can't load a version 1 and a version 2 of a library at the same time into a single process. And if an application has a link to version 1 and version 2 and needs them both, because that language can't load them both, the application simply can't run at all. Now, for languages that can do this, and there are some that can, there are still some significant problems with it, such as size. Especially for things like JavaScript, it can load different versions at the same time, but it has to download those and load them in the same process, so the size is much bigger. And also, if there's any singletons in these libraries, well, you now have a version 1 singleton and a version 2 singleton, so they're not unified anymore, and maybe they're doing some client-side caching of resources. Now you have two separate caches instead of a single unified cache. So while in some languages it may be possible, there are still reasons why this is not ideal related to size and multiple singletons. Also, when you make a breaking change to the service or to a client library, that affects or invalidates the entire ecosystem. There may be third-party libraries out there that are using a library. There may be documentation written for your libraries, and there probably is documentation. There are samples out there, there are blog posts, there are videos. So when customers are trying to learn how to use a service, they might look up online how to call a method. Well, if you've changed the parameters to that method, the order, the names, the data types, then the customer might find a blog post or video online that explains how to do something, but because you've now changed it in your service, that information is no longer valid. And now the customer can't trust these things anymore to know if they're applicable to the version of the library, the latest version of the library that they are now working with. So let me explain a little bit more about this. The first bullet here, where many languages can't load two different versions of a library at the same time. Let's say that we have a client that's building their application, and the customer's application takes a dependency on some client library, version 1.3. And the application also takes a dependency on a third-party client library, we'll call it library A, and that library takes a dependency on the same client library, but version 1.0. And the application also wants to take a dependency on another third-party client library, we'll call it library B, but this one has taken dependency on the latest version of the same client library, version 2. Now, we can assume that version 1.3 is a backward compatible, just a later version of client library 1.0. But we could assume that client library 2.0 is not backward compatible with version 1.0 because maybe it had some breaking changes in it. Well, this is all fine and this may build perfectly fine, but at runtime, we're going to try to load into a process the app, the library A, And then the app needs client library 1.3 and library A needs client library 1.0. Well, only one of those will be loaded at runtime, and it will be the latest version typically. So that will be client library 1.3. So now the app and library A will both be using client library 1.3, and hopefully that's backward compatible with 1.0, so everything should work fine. But now when the process tries to load library B, it requires client library 2.0. But as I said before, a lot of programming languages can't load both of these, version 1 and version 2 at the same time into the process. And so the language can't load library 2, the whole process can't run now, and the app is completely unusable at this point. And this happened because we introduced a breaking change somewhere, some other thing took a dependency on it, and now we need to load two different versions at the same time, but the process can't do it, or the language can't do it. And so now the application is completely unrunnable, and we've put the customer who's building this application, or really all customers of the third-party library B2 potentially, into a very bad state where they can't go and talk to our service anymore. So we have a versioning strategy. And the strategy is that we should use an API version query parameter to signal new features that are getting added into a service. And I show an example here of talking to the api.contoso.com web server. And I'm going to the users and /Jeffrey to do something to the Jeffrey resource in there. And then we always add a query parameter of API version equals some value. And usually our values are date-based, like 10/21/07/27. We also recommend that this is as a preview of the service that you would append to the end of the API version -preview dot and then a number, like in this example 1. And I'll talk more about this versioning previews a little bit later on. Do not put the version in the URL path. The path identifies a resource regardless of the version. Earlier in the course, I mentioned that the path is identity to a resource, and I can create that resource today, and 100 years from now, I could use the same path to access that resource later. The path is supposed to be a stable identifier for the resource. So if you put a version number in the path, then it's tied to a particular version, and it's something that you very rarely want, is to create a resource that's tied to a specific version. Usually you want the resource to live over multiple versions of the service. So using this API version mechanism, customers can opt into new features if and when they desire, right? So it's under the customer control, not under the service control. As long as the customer is passing in an API version for a particular value, and they keep passing that in over and over and over again, they should be getting the same behavior that they got before, and everything should work. If the customer wants to leverage some new features that are available, then they can go, then your service can ship the new version, tell customers what the new API version is. The customers can then on their time schedule go and change the API version they're using to the new one in order to leverage new behavior or new functionality that the service provides. Note that happy customers may never opt into new features. There's a lot of customers that go and build their app, they have it running, you know, it's the back end of their website or something, and it just runs and it works great. And while services may add feature A and feature B and feature C, these may be esoteric features that mainstream customers don't really have a need for. And so they may never go and change the API version at all. And this is another useful thing about having telemetry, or if the service records or logs the requests, it can see what API versions are being used by clients. So they can tell how quick adoption is happening of new service versions that get introduced. If the customer does opt in to using a new version, they should simply just have to change the version and everything should work as perfectly fine. But then if they want to, they can modify their code in order to leverage new features. So versioning of an API is really a misnomer. You're not actually versioning the service. What you're doing is you're really adding new APIs, and you're stating that the newer version is preferred, but it's not mandatory. New versions really run alongside as the previous versions. So existing clients, they will always get the same behavior they got, and they're never being forced to upgrade. And then newer clients, they can talk to the newer versions and they can use that and everything should work great. Let's talk about service versions and client libraries now. Well, different clouds can support different versions of a service. In Azure, we have public clouds, and then we also have Azure Stack Hub. And it could be that we have a service running in the public cloud, and maybe it supports 3 different API versions. But maybe in Azure Stack Hub, we have the same service running there, but it may only support one of those versions. And because it's customers who control when to upgrade Azure Stack Hub, whereas Microsoft controls how to update their public cloud data centers. So a customer who wants to leverage this service can go and grab a client library in the language of their choice, that means the SDK of their choice, that they wish to use to go and talk to the service. Now, if the customer knows they're talking about against Azure Stack, then they have to get a version of the client library that supports the 2019 version. If the customer knows they're talking to a public data center, then they could get a version of the client library that talks to 2019, 2020, or the 2021 version. Right? But the customer has to know what cloud they're talking to and what version of the service is there. And then the customers have to be able to look in documentation for the client library to indicate what version of the service a client library supports. Now, to reduce customer pain, Microsoft's client libraries try to be backward compatible. That is, the API version can be a parameter that's passed in when the customer is creating a client in their source code. And then when they make requests to the service, that API version is the one that will be passed from the client to the server. Now, this assumes that later versions are backward compatible with newer versions, of course. And if that's not the case, then this is not guaranteed to work. So we're trying to simplify for customers that there's not this version of the client library for this version of the service, this version of the client library for this version of the service. What we're trying to say is this client library supports these versions of the service. And then the customer can grab any client library that supports the version they want to talk to, and newer ones should support later ones of the service. Newer client libraries support later versions of the service. And then the customer can grab the latest one, and then it can work backwards in time with API versions. And this makes it much simpler for customers to rationalize about this, understand what's going on, but it really only works if the services maintain backward compatibility between the different API versions. As I've mentioned many times, a services API is a contract with the customers. So any contract change, that is any change to the API, it really requires a new API version. Even additive changes require this, or ambiguities will arise. So let's say, for example, that in some cloud, there's a 2019 version of a service. And then that service team decides to go and add some new optional property to a response or to a request, or add some new API that's supported, but they don't change the version of the service. So it's still 2019-01-24. Well, this failure to change the API version can cause confusion. So let's go through a couple of examples. The first is, when looking at the documentation for this API version, does that documentation include the new feature or not? Let's say it does include the new feature because you've updated the documentation. Great. But on some cloud, that cloud may not have the latest version of this version of the API. And so when the customer's code tries to use this new feature, but to the same API version, but that version on some cloud doesn't support it, the call fails. And the customer won't understand why. Because they'll say, the servers will say, this is an unknown operation. And the customer will say, well, the documentation says it's there. It's the same API version that I'm using. So what do you mean unknown operation? And now the customer has no idea what to do. This usually will end up meaning a call to customer support to try to figure this out. And the customer support people also can't figure it out for the same reason. And so it's a problem the customer has that's very hard to diagnose and fix. Also, does a client library for an API version include the new feature or not? So if you add some new API in a same version of a service, and then we create a client library, we document that this client library is for this API version of the service, but was it version 1 of that API version that didn't have the feature, or is it version 2 of that API version that does have the feature, right? It's very confusing, and so don't do this. When you change the contract at all for your service, change the API version so that it all makes rational sense. This slide walks through the service versioning workflow. Let's say that you already have a service that's currently in general availability, and we'll say that its API version is 2020-0111. Now that has been shipping and you have customers using it, you would like to start working on the next version of your service. And you might start off with having a private preview. So let's say that for version 2 of the service, we're call the API version 2020-02-22. But because this is in preview, we'll append the suffix -preview.1 to the end of the API version. Inside your OpenAPI specification, you would indicate that this is based on the 2020-0111 version. So this is a later version that was originally based on the version 1. The reason why this is useful is that we have tooling in Azure that when you check in your open APIs into a GitHub repo, we can make sure that anything that's inside this contract document, we can compare it against version 1 to see if you've done any breaking changes, and then we can flag them and not allow the PR to be merged into the repo. Now, during this preview period, breaks to the preview are allowed in here. And because this is a private preview, you know who all the customers are. So if you decide you want to make any breaking changes in here, it's okay, but you need to notify all your customers that this break is happening and what time frame it's going to happen, so that your customers who are using the preview, they know to update their code. Because this is a private preview, you know who all your customers are, and you can reach out to all of them. Now let's say that you're transition. Now, another thing you can do is while you're in private preview, you can increment this number. So if you make a breaking change that's part of the preview, then you can put out the 2020-02-22-preview 2 version, and then your current preview customers are calling .1. Your new preview can be called by customers using the .2, and then our policy is that within 90 days, you can go and deprecate the preview.1 entirely. Again, notify all your customers, but this allows you to put the new preview bits in production right away. You're not breaking the old customers using the old preview, and they can migrate over, but then you're only giving them 90 days, your preview customers, to forcefully move them. Eventually, you'll go from private preview into public preview. And when you do that, the API versioning scheme doesn't change at all. But now, you don't know who all your customers are, because now you're in public preview. So lots of customers may be using the service, and you don't have a direct way to communicate with them. So now, whenever you want to make a breaking change to the preview bits, you must increment the number after the preview dot. And then you notify customers there's preview 2, preview 3, preview 4 is available. They should update their code to talk to the latest preview. And then 90 days from now, you will be removing support from the previous previews. So your previews customers, they have to migrate to the new previews. Eventually, you'll be happy with your preview, and now you think your new version of the service is ready to go into general availability. So to do that, all you need to do is remove support for the -preview suffix, and now your new version is in GA, and it's version 2020-02-22. The previous version was the 2020-0111, and again, that base version is always used to make sure there was no breaking change with the previous GA version. Here, our tooling in the GitHub repos validates that. Once you've gone to production, then your service can give customers 90 days, your preview customers 90 days, and then you can take all the preview versions away and stop supporting them in your service. You're forcing your preview customers to upgrade to the GA version now within that 90-day time period. And then any changes you want to make to this GA, then this whole cycle just starts all over again, where you create a new private preview, then a public preview, and then when you're ready, you put version 3 into general availability. Now, we do have a policy in Azure that if you want to make a breaking change between GAs, it is possible to do so, but we notify customers that the breaking change is going to happen, and then you cannot make the breaking change for 3 years. So you're effectively forcing customers to migrate to the new breaking change version, but they have 3 years to do it. As opposed to in previews, we're giving customers only 90 days to do it, but they knew it was a preview. They knew that they had to stay on top of it. For things that are in GA and customers have their production workloads talking to GA, we feel it's necessary to give them a greater time span in order to adopt any breaking changes. So it's possible to make breaking changes for between GA versions of a service, but we want to make that bar very high and difficult, so you notify customers and then you can't force them to upgrade their code. Yeah, you have 3 years to upgrade their code, and then you can stop supporting the previous thing because you've made the breaking change. Well, again, we strongly discourage this.